Hello, I'm Daryl Sealand, Editorial Director of Quality. I'm here with Dan Howe and Len Chamberlain to discuss 3D scanning. Dan is a Regional Development Manager for LMI Technologies and an expert in 3D machine vision for factory automation applications, including a focus on laser line profiling and structured light techniques for automation, quality control, and process optimization. Len earned a mechanical engineering degree from the University of Colorado and spent the beginning of his career designing medical equipment and production processes for Gambro and Medtronic. When Geomagic was purchased by 3D Systems, he became the VP of Sales for the entire software division of that company. Thanks to you both for joining me today.
Nice to meet you, Daryl.
Nice to meet you as well, Daryl.
Excellent. So let's start off. Can you both tell us a little bit about your experience and your background in 3D scanning?
Sure. I started with LMI Technologies back in 1998, so I've been in this industry for about 23 years. And some of the first stuff that I did was actually related to the transportation industry, looking at the 3D dimensions of pavement, which is actually something that's used in assessing roads, looking at texture, rut shape, things like that. But over the years, that's expanded into all sorts of industries. So it's really fun to see the different applications that 3D is applied to.
I started about the same time, I think 1996, working with laser-based triangulation scanners, primarily for reverse engineering and offline inspection. And I've worked both in the hardware industry and the software industry. I started with LMI about 7 years ago and was really attracted to taking the 3D scanning technology that I have used offline and looking at inline solutions, something that could really be deployed en masse and be effective in terms of helping production lines gain greater efficiency and greater quality as an output product.
What types of 3D scanning methods are there out there?
Well, there's a lot of different methods that people may be familiar with, some of which are kind of more long range and some are shorter range with higher resolutions. Only a few of those are typically used in your quality control manufacturing environment. But it ranges from things like LiDAR, which is a large range scanning technique using time of flight with pulsed light, which people might be familiar with. That might be used in your self-driving cars as well as terrain mapping, things like that. There is a technique called pseudo-random dot, which is typically a dot pattern that's projected using infrared light. That's a technique that is low cost, low resolution, so typically around 5 millimeters to 10 millimeters. That's used in a product like the Microsoft Kinect, which people might be familiar with the gaming platforms. But then when you get into inspection, you're typically with things that we use like fringe projection, which is a structured light technique for area scanning, typically on the order of a meter or less in size of your object, gets you down to sub-millimeter. And we use a lot of line triangulation, so that's laser line with cameras, and you can get down into the tens of microns or even single micron resolutions, all the way down to techniques like confocal, which can be sub-micron, and even interferometry, which is something that we don't use. It's typically something you use in a lab. That'll get you down into nanometers, even angstroms.
As Dan mentioned, it's a pretty broad range when people talk about 3D vision and 3D scanning. And so LMI's focus and the focus of this talk is really the technologies that are most applicable to the production line, things that are capable of high speed and high accuracy.
And which industries would use these 3D scanning and measurement methods?
There's a big range. We started a long time ago in the lumber industry, believe it or not. So people that would scan a log to determine its shape and figure out how to cut that log to get the most yield, as well as scanning boards. But it ranges from things like automotive, looking at sheet metal, to engine components, into rubber and tire. There's actually quite a bit of measurement done on the tire building process, all the way through things like food, packaging, but then you get down to real high resolution stuff with consumer electronics, so things that are on cell phones or tablets, or measuring products like medical devices. So it can be pretty much any industry you can think of.
We really ride the same wave as automation does in general. So where you find automated production lines and automated processes, you find 3D machine vision and 3D inspection in line. So it's really exciting place to be, and it's one of the reasons I really enjoy this job, is that there is such a huge variety of applications that we address.
Of all of these 3D scanning methods you just mentioned, which works best for industrial factory applications, and why?
So typically in factory inspection, the techniques that are used most is fringe projection, laser line triangulation, and confocal technology. And that's basically because they have the types of resolutions that are required in the factory inspection applications, as well as the speed.
Fringe projection is typically used with stationary parts where there's no relative movement between the sensor and the object being inspected. That can also be used in an end-of-arm robotic application. Line triangulation and confocal are typically on a conveyor, so you need some relative movement to pass the part underneath the sensor, and you're taking those measurements as the part passes.
And how does one choose the best technology for a specific application?
So a lot of it starts really with testing, using different types of techniques, different sensor models to determine which one actually does the job. But one of the other criteria is understanding the cost of the different techniques and making sure that you're matching up the required resolutions with the budget to get the proper return on investment.
Yeah, most suppliers in this space will allow the production line to evaluate different sensors, and I think that's an important piece because it's hard to have an innate feel of what sort of resolution is really required to detect the defects that you are finding in your parts. So I would always recommend working with somebody who's well familiar with the space and getting an eval for your particular application. Besides the cost, I think speed is another one that we hit upon earlier. Your production line speed is going to drive significantly what you're able to measure and what sort of computing power is needed to be able to process the data at that rate.
And how do users use these sensors, and how do they handle the massive amounts of data that's going to be collected?
Yeah, so the 3D sensors are only as good as what you can do with that data. So it's critical that they have software and measurement tools that go with it. And we provide what we call smart sensors, and these have onboard processors that do edge computing. So you might get from a scanner millions of points per second produced, millions of 3D points, and you don't want to necessarily pass all that data off to some computer sitting somewhere because it's very difficult to do. So when you're measuring something, you may gather all those points, but you're really only interested in a few critical dimensions of that component. And with edge computing, you're actually doing this processing on the sensor itself. And so determining from that data what measurements are important to the customer. Maybe you're finding the position of a hole and understanding its position relative to some other feature on the object. And the sensor itself can provide either that measurement value or perhaps even just a pass-fail, where it's just sending this is good or this is bad.
Now, many years ago, when I first ran across this technology, I thought, well, gosh, it's going to revolutionize the industry. And some 20 years later, it is now starting to happen. And I think it really had to do with the ability to process data where the data was taken. So the edge computing that Dan mentioned. We've got applications where when we're scanning large parts at high resolutions, it's easy to generate scan files that are 0.5 gigabyte per part. And that's not something that you really can manage if you've got to pump that through the factory's network in order to get a decision back. And so with the advent of ARM processors inside the sensors themselves, it allows them to make those pass-fail decisions right on the line, only save the data that is really relevant to that process, and keep the production line moving at the pace that's expected. So it's been a real transformative event for us.
Is artificial intelligence and deep learning being used in these applications?
Yes, it's beginning to. That technology has hit a point where it is very viable in a lot of different industries, and certainly in the machine vision industry. Depending on the type of feature you're looking for, it may be required. We do have a lot of measurement tools that we call, rules-based. So that's really setting up tools without artificial intelligence, and that's typically looking for features, positions of features. But when you get to defect detection, things that maybe aren't necessarily as easily defined as to what makes it good and bad, that's really where artificial intelligence and deep learning come to play, where you can teach the sensor what is good, what is bad, and the AI figures out what criteria defines that.
Correct. There are applications that are outside, strictly speaking, quality there as well. So where you're classifying certain types of objects, you might be grading meat or grading lumber, for example. But on the pure inspection front, artificial intelligence tends to be replacing more human operators that are looking for cosmetic defects, something that is harder to define on a CAD file, for example. But it is a tremendous area of growth, and it really broadens the applications for which 3D sensors can be used. And I'm particularly excited about the intersection between artificial intelligence and the use of 3D data. That is a space which is really early in its development, but has a lot of potential.
Thank you both very much for your time. We really appreciate it.
Great.
Thank you,
very much.
For more products from Quality, please visit qualitymag.com.